Hello, I'm Professor Rad, and today we're going to talk about how to multiply fractions by using the prime factorization method. So in the last video, we talked about a very direct way of multiplying fractions. You multiply across the top, you multiply across the bottom, and then you simplify. One of the downsides to that very direct method was that sometimes you get really big numbers, and so multiplying by hand and then also simplifying, especially by hand, can be pretty challenging. So this technique is very useful if you're working by hand or if you're going into algebra in the future. So if you have to take like an intermediate algebra, or if you know eventually you need pre-calc or calculus, this technique is really handy because it generalizes well to things that have variables. In other words, it works well when you have things that have letters in them. So it's kind of a more roundabout way, but it's a little bit easier without a calculator, especially if you know your multiplication tables. And it basically reverses the order so that instead of multiplying and then simplifying, we're essentially going to be simplifying and then multiplying our results. So what we're going to do is find the prime factorization of the numerators and then the prime factorization of the denominators. And then you cancel factors the same way that you did when you're simplifying. So as long as something from one of the top factors cancels with something in the bottom, then the canceling will work. And it won't matter whether they're from the same fraction or not. And then you multiply whatever's left up top, and you multiply whatever's left in the bottom. Kind of just like what you do when you multiply using the prime factorization. So let's work through a few examples of using this technique. Now, just like in the last video, these first examples have some smaller numbers for us to work with, and then the last one is going to have some bigger numbers. So we'll see kind of a comparison to how it felt to do the problems in the last video. So I'm going to start out with 5/7 times 4/25. Now the good news here is that 5 and 7 are both prime, so they don't break down at all. We're going to keep that as 5/7. The other good news is that 4 is the same as 2 times 2, and 25 is the same as 5 times 5. So because I know that, and I know that it just breaks into two prime factors, I don't necessarily have to make a factor tree, although you certainly can if you want. So 4 is the same as 2 times 2, and those are both prime. And 25 is the same as 5 times 5, and those are both prime. So I can rewrite 4 as 2 times 2, and I can rewrite 25 as 5 times 5. Then comes the fun part. Now I can cancel any factor that I see up top that has a match in the bottom. They can be in the same fractions or different fractions. What matters is it's in the top and the bottom to match up. So for example, this 5 here can cancel with one of the two 5s in the bottom on the second fraction. So I'm going to cancel the 5 with the first 5 on the bottom. And for this one, that's all that cancels, because then I just have a couple of 2's on top, and there aren't any 2's left below. So I multiply what remains up top. 2 times 2 is 4. And then I multiply what remains on the bottom. 7 times 5 is 35. And that's it. This will be our final answer. All right, now let's take a look at the second fraction, or second product that we have to find. We've got 3/14 times 7. Now, when you're multiplying by a whole number, it helps to put it in fraction format so that you're multiplying the same kinds of numbers. So I'm going to put 7 as 7 over 1. And remember, we can do that with any whole number. You can write it in fraction form just by putting it over 1, since 7 divided by 1 is 7. Now the nice part about this is 3 and 7 are prime, and 1 is neither prime nor composite, it's just 1. So we're just going to leave it as 1. So the only one we have to factor out is 14. 14, easy to break down. It's just 2 times 7. And both of those numbers are prime. So I can rewrite this as 3 over 2 times 7. And then we have times 7 over 1. Now we can cancel anything up top with anything below. So I notice that there's a 7 here on top and there's a 7 below. So those two can cancel each other out. And then the only factor that remains up top is the 3, and there's nowhere downstairs for it to cancel out with. So I have 3 left in the numerator and 2 times 1 in the denominator. So I have 3 over 2, and that's my final answer. So if I compare these to when we worked through these problems using the direct method, I think it kind of looks pretty similar. So over here, when we did 5/7 times 4/25, I did have to do a little bit of work in finding my factor trees, and then the multiplying with the canceling, not too bad. So most of my work here was in the factor trees, whereas when we worked through this one in the direct method, most of the work was in the multiplying, the larger number, and in the dividing to do the simplifying. Also notice that this division by 5 is what we did to simplify. And over here, our factor that canceled was 5. So essentially what we're doing here is we're simplifying first and then multiplying what's left. Whereas in the direct method, you multiply first and then you simplify after. So if the numbers aren't too big, both of the methods are pretty comparable. But if your numbers are larger, I kind of like this technique better. So let's do an example where we have some larger numbers. Okay, so for example C, we're going to find 33 over 34 times 85 over 99. So much bigger numbers. And this time I'm going to have to create a factor tree for all 4 numbers. So let's just go ahead and do that. So for 33, that's going to be 3 times 11. Again, you can use your calculator to help you do this. If you know your multiplication table, it's a little bit easier. I also know, for example, for 99, that's another easy one to factor. So when you have those double digits like that, you know 11 will be one of the factors. So 99 is 9 times 11. And then the 9 is going to split up into 3 times 3. All right, now let's try this 34. I know 2 is going to work because 34 is even, but I don't know how many times. So let's use my calculator to help me out, do this dividing. I get 17. Now 17 is one of our prime numbers, so we can circle that one as well. And then let's see, we did 33, 34, we haven't done 85 yet, and we did the 99. Okay. Now with 85, it ends in a 5, so I know that 5 is going to be one of the prime factors. But again, I don't know how many times. So 85 divided by 5, works out to be 17. Sweet. Okay, so now we've made our factor trees over on the side. So now in the main problem, we're going to put them where they belong, right? So 33 was 3 times 11. And 34 was 2 times 17. Then we had 85, which was 5 times 17, and 99, which was 3 times 3 times 11. All right, cool. Now comes the fun part, anything that we can cancel away. So this one, there's actually quite a bit to cancel. So the 11 caught my attention right away when I did the prime factorizations. So this 11 from the top can cancel with this 11 in the bottom. Oh, it looks like we also have a 17 in the top and in the bottom, so those can cancel out. And we have a 3 in the top and a couple of the 3's in the bottom. So it doesn't matter which of the 3's in the bottom it cancels with, just cancels with one of them. And that's it, because the only thing that's left up top is the 5, and there aren't any 5's below. So it looks like for our numerator, we're going to have 5, and in the denominator, 2 times 3 is going to be 6. So we have 5, 6 as our answer. So one of the reasons that I like this method better for larger numbers is because if we go ahead and multiply 33 by 85 and 34 by 99, when we did that before, we got these massive numbers, 2805 and 3366. So first of all, multiplying the numbers was a bit of a chore, right? Because they were both 2 digits. And then once we got these big numbers as our answers, trying to figure out how to break them down was kind of tricky. So we weren't sure what was going to go into both the top and the bottom. Whereas here, what we're doing by doing our factor trees first is that we're taking those numbers and we're breaking them down before they get bigger. So instead of having a 2805, for example, we break down the 33 and the 85 first. And then the same thing with the denominators. So what that does is it sort of uncovers all of the factors hiding out that eventually we would have been able to divide by. So I like this method for bigger numbers because you're breaking down smaller numbers before they get big. The downside is it's less straightforward, so it's easier to kind of like lose the flow and lose the path that you're on. So again, it's just kind of up to you which method you like better. Whichever technique you find works better for you, that's going to work great for me. So I've got some Now You Try problems that ask you to use the prime factorization method to try it out and see if you like it here. In the next video, we're going to be talking about something called a multiplicative inverse and multiplicative identity. So I'm looking forward to seeing you there. In the meantime, have a great day. Bye.